start with 10. They didn't give you, you're listing angles. Did they give you all the sides in number 10? They didn't give you all the sides, did they? But they did give you 105. What can you tell me about 105 based on all three? What do we know about 105? Why must it be the biggest? So 105 is the largest because can you have more than one obtuse? So what's your largest side? CD. Opposite E is the largest side, which is CD. What did they say? From smallest to largest. So we know that's going to be there. So this is large. Now, then they gave you an X, and they gave you a 3X. Now, do you agree X is the same number? Okay, if X is the same number, can you have negatives? No. So who has to be bigger, X or 3X? Does that make sense? So who's medium? Which side is medium? ED. And then which side is the smallest? CE. So that's how you do 10. Now we're going to go to 34. Find the longest side. Oh, I like 34. This one? CD is the largest. Oh, okay. I have used my little signs just totally inappropriately. Is that better, MJ? Is that good? Thank you for seeing that. All right, we have an ABC. This was 34. All right, we've got A, we've got B, we've got C. They've told us that A is 70. They've told us that B is 2x minus 10. And they've told us that C is 3x plus 20. If I want to order the sides, what do I have to know? What do I have to know, Nick, if I want to order the sides? Right, I need X, and then X is going to give me what? Right. So we're going to have to, how do we find X, Carlin? Excellent, yes, and set them equal to what? So we got 70 plus 2x minus 10 plus 3x plus 20, and that is 180. So 70 subtract 10 is 60 plus 2 is 80. 2x, 3x is 5x. All right, and so we subtract 80, we'll have 100. Divide by 5, we have 20. So we know this is 70. How do I get B? So B is going to be 2 times 20 minus 10, which is 40 minus 10, which is what? 30. And then we got 3x plus 20 down here, so we're going to have 3 times 20 plus 20 is 60, 70, 80. All right, we want to, let's see, what did they say? Longest side. Who's longest? A, B. Next question. Caitlin. Okay, they want to know the angles. All right. 11's kind of similar to 10. You've got this triangle, and what's special about that angle? This angle right here, what's special about that? It's 90 degrees. Can you have two 90-degree angles? Can you have an angle larger than 90 with a 90? So what do we know is the longest side? Which one's longest? GH, because it's opposite 90. Okay, now, if that's the longest, where's the medium? Because that's 6. And where's the small? HJ. So they want small to large. Am I doing well? So then we've got GH. Next. Tommy? 49. 1 and 2 are corresponding angles formed by two parallel lines in a transversal. What's the relationship between corresponding angles if lines are parallel, Tommy? Pardon? What do we know about corresponding angles if lines are parallel? Right. And they told you that 1 and 2 are corresponding. So 1 is 33x plus 2, and 2 is 68. So 33x subtract 2 is 66. X is going to be 2. And what did they ask for? Value of x. Next question. That was like a review. Unfortunately, when we met this over a break, we didn't put in any reviews. So you're good with the rest? Going on? Yes. 16? 16 wants us to list the sides. 15? Okay, 15 wants us to list the sides. So here's 15, and I need to know the letters. What do we have? M and O. They told us that this is 75, and this is 45. How do you find M, Bree? $45, 75 is 10. That's going to be 11 plus 1 is 12. Then what? 180 minus 120 is 60. So can you order them now? They want them ordered from shortest. What's the shortest? Okay, O is the smallest angle, but we're looking for sides. So what's opposite 45? There you go. Okay, where's the medium angle? ON. And then what is the biggest? Right. Other questions? All right, before I forget, why don't we pass our homework to the center? Wait a minute. Nick had a question on the warm-up. Which warm-up was it? What did it look like? Did you draw a picture? Anybody have a picture drawn for the warm-up? Okay, you were given this triangle. You were told those are parallel. And you were told that angle 1 was 3x minus 5. You were told that this is 2x plus 15, and this actually extended. And you were told that that angle was 145. Thank you, Becky. Nick, do you need this segment? No. What are you going to have to do? Okay, but how are you going to do that? Okay, what tells you those are equal? Are there parallel lines? No. Same side interior would be supplementary, but there's no parallel lines. Okay, so now we're going to add them. Is that good enough? Where's our x? Okay, but we can't use that x because they didn't give us this to be x. What is that third angle? There you go. So 8, that becomes 7. 10 subtract 5 is 5. 7 subtract 4 is 3. This is 35. Now what are you going to do? There you go. Finish that and turn it in. Everybody else, pass your papers to the center, please. So one of the, I guess you could say, skills is to be able to look at it. I've already had that if we had gone in order of the book. All right, so it says we've done compared transformations that preserve distance. Oh, we got to start here, distance formula. This is from Algebra 1. The distance between any 2 points on the coordinate plane where one ordered pair is x sub 1, y sub 1. It's sub 1 because this is the first. And then we've got x2, y2. Those are sub 2 because it's the second. Distance is going to be the square root of the difference of the x's squared plus the difference in the y's. Now, is this on the reference sheet? No, it is not. Okay? It is not. So you have to what? Know this. Do you have your major geometric term sheet? Find it. And you're going to put, I want this on your major geometric term sheet. I like where you have yours, Karen. So what does the first column say? It says term, we want distance between 2 points. So the first column, you should have distance. How about if we do distance between, bless you, x1, y1, and x2, y2. So that's your first column. And then in your second column, you are going to write the formula. Okay, second column, I want the formula written. We're good. Okay? This is something that you've got to know. And you're going to be using this for the rest of the semester. They call this coordinate geometry. They call this coordinate geometry because we are using geometric figures on a coordinate plane. And this is a big deal. You're going to see a lot of this on the test. It's a big deal. And when we get into the polygon unit, you're going to have to show that something's a square because the sides are equal. The only way you can do that is to use your distance formula. No, doesn't matter. As long as if you start with 1 minus 2, you do 1 minus 2. Now, what we learned in the very beginning of the year, this is x1, right? That's my first x. And this is my second x. So we learned in the beginning of the year, if you want to find the length of a segment, that it's going to be the right minus the left. That's that length. This happens to be, this point is y1 high. So this would be y1, and this point happens to be y2 high. So if you wanted to find this length, it would be y2 take away y1. Then what they did is they did the Pythagorean theorem. They said this distance, which is what we're looking for, squared, is equal to x2 take away x1 squared, let's be a parenthesis, plus y2 take away y1 squared. Now, how do you undo a square when you're equation solving? Square root. So when you square root both sides, and distances are always positive, I'll put the plus or minus here for Algebra 2, distance is equal to, we choose the positive because we don't do a negative distance. That's where that came from. Direct result of the Pythagorean theorem, which you all do very well with. So I need you to be able to And there's several questions on this assignment that are critically important because those are the only ones you're going to have practice for on the distance formula. So if I want to find the distance between those two ordered pairs, this is x1, y1, this is x2, y2, we're going to say distance equals, and if I were you, I would write this formula every time you use it because that puts it into long-term memory. Makes your studying a lot easier when things are in long-term memory. So my x2 is -1, my x1 is 3, and we square that, added to. My y2 is 4, my y1 is 5. And if you're messing up, put these on top so you can see who x1, y1, x2, y2 is. My daughter needed to do that. She did that, she got them right. So I like to do this because that's just me. -1 plus -3 is -4 squared. And 4 plus -5 is -1 squared. Squaring -4 is 16. -1 times -1 is 1. This is going to be square root of 17. Now, if you want the distance, you'd have to get a calculator out, which I do not have. Notice that I use a calculator on any of my computations. I strongly suggest you get your calculators because half of your EOC is no calculator. And if you haven't practiced your arithmetic, then you're going to be rusty on the EOC, and it'd be sad to fail the EOC because of arithmetic. All right, Jeff, help me. This is? Okay. Good. And what do you do to this? How many people remember this from Algebra 1? 2? Couple, all right. You probably did this either in the exponent or the quadratic unit. All right. I like to do plus negative. What's -9 and -6, Samantha? $15? Okay, and now that's going to be plus a positive, so what's 5 plus 8? 13. All right, so when you square -15 times -15, that is 225. 13 squared is 169. I do not know what these are, so let's look. So 9 plus 5 is 14. Carry your 1. 6, 7, 8, 9. 2 plus 1 is 3. So this is going to be the square root of 394. Any questions on your distance formula? You're going to be using that on one of your problems. You know what? I could look and see. I'm going backwards in the book. Let's see, section 4.1. Not the second I'm teaching. All right, so when you get to A47, they're asking you for the lengths of KL, LM, and KM. And they've given you vertices of its congruent triangle. So I need you to do 47. I need you to do it well because that's probably going to be your only practice on distance formula. All right, congruent polygons. That means many-sided figure, in case you didn't know. Many-sided figure are polygons whose corresponding sides and corresponding angles are congruent. If you recall, rigid transformations are transformations that preserve angle measure and lengths. This is old stuff. And you all told me translation. You told me reflection. You told me rotation. And you told me glide reflection. You told me all of those. Which one does not preserve? What's our other one? You had to do it on your last project. Dilation. A dilation does not preserve length, but what does it preserve? Angle measure. Okay, dilations do not preserve length. They preserve angle measure. So there's a blast from the past. But they expect you to link our congruent polygon unit to our transformation unit. So the more we can circle back and the more we can remember what we've done in the past, the more prepared you are for your EOC. Okay. Can triangle ASK be placed on top of DOG through one or a composition of transformations? Can you do it? Yes. What kind? A reflection. We would flip it, correct? Now, did I do a good job on the way I did my triangle lettering? A, S, K, D, O, G. Do you remember how you have to do this so that A falls on top of what it corresponds to? You with me? You remember? Okay. And S has to fall on O, and K has to fall on D. That's a huge piece of what we're doing. If so, are they congruent? Yes or no? Yes. Why? Because reflections are rigid transformations. Or reflections are an isometry. Rigid transformations. Or you could say it's an isometry which preserves angle measure and length. All right, so one of the important pieces today is that you remember the way we have to correspond our letters. And that's going to be a big piece of 4.2, 4.3. It's going to be very important beginning Tuesday that you have your binders with you every day, because we're going to do about 7 investigations all at once. I'm going to investigate a lot. Okay, naming congruent figures. So if I want to say triangle KAS. All right, so Kayla E, how do you do the other one? What corresponds to K? And then to A? A's down here. D, and then to S? Right, okay? So once this is stated, there is only one correct way to write that. You've got to pay attention to that order. Now, they're going to ask you to name the corresponding parts. So how many angles are there in this picture? How many angles are there in the triangle, Hope? 3. So you should have 3 angle congruent statements. So if I look at the first triangle, angle A is congruent to what, Eric? D. Angle S is congruent to what, Bree? And angle K is congruent to what, Brittany? G. All right. How many sides are in a triangle, Leslie? 3. So you should have 3 different side statements. Now, if there were 4 sides, you'd have 4 of them. All right. You've got to make sure you correspond. AS corresponds to what? Caitlin? AS? Okay, you did a great job. You cannot do OD because O does not correspond to A, because A came first, D has to come first. S came second, O comes second. All right, Sydney, SK. OG. Because S was first, O has to be first. AK, Becky? Okay, got to correspond. A came first. DG. All right? Everything we do is going to be this picky. And this is, you're going to be doing tons of this entire chapter. All right, so here's a word map, congruent polygons. I'll think about that one. All right, quadrilateral cars is congruent to quadrilateral meow. CARSMEOW, okay? So if I had not drawn these pictures, you should have been able to tell me what angles correspond to what angles, etc. But anyway, what transformation maps cars to meow? Translation, it's a slide. So let's get some algebra. If AR is 6x minus 1 and EO is 4x plus 11, what equation am I going to write, Tommy? Why? Because if the polygons are congruent, their corresponding sides are congruent, correct? All right, so now you're going to add 1 to both sides. So that's going to give you 2x equals 12 or x equals 6. So we need to link chapter 9 to our chapter 4. All right, now, do you see my statement? See it? There is no picture. Now, you certainly could draw a picture. CBS can be mapped onto a triangle FOX through a glide reflection. Draw a diagram to illustrate this. So what must be true about these two triangles? What do I have to do a glide reflection? What do I have to do? Translation and reflection. So I think what I'm going to do is I'm going to do my reflection. Do you see the reflection? All right, so now help me label this. What should this vertex be? F, O, or X? Pardon? F? What should this one be? O, and this one? Right. If angle B is 2x plus 3, and angle S is 4x minus 7, and angle C is 3x minus 5, if I have all these angles over here, can you find O? What angle do you have to find O? B, exactly. So what equation are you going to write, Brittany? 2x plus 3. Right, equals 180. Some of the angles in a triangle are 180. Carlin, 2x, 4x, 3x is 9x. And let's see, Kayla S, 3 subtract 7 subtract 5. Well, 3 subtract 7 is, and then subtract 5. Right. So you're going to add 9, so you get 189. You'll divide by 9, you're going to get 21. Is that what we wanted? We need O. O corresponds to B, and B is 2x plus 3. So the measure of angle O is going to be 2 times 21 plus 3, which is 42 plus 3, which is 45. Are you finding this hard or easy? Easy? Okay. So there's one. All right. Are the triangles congruent? To be congruent, what must be true? All sides must be equal. Well, is this side equal to something over here? See the tick mark? All right. Is this side here equal to another one? Yeah, up here, correct? All right, and is this side equal to something over here? All right, so are all my sides congruent? All right, we know that this angle is equal to that angle because of the double tick marks, yes? We know this angle is equal to that angle because of the what? Single arc. What about these angles? Do we know anything about those? Pardon? Well, the angles. Do we know anything about those angles? Vertical. What do you know about vertical angles? Congruent. That is huge in this chapter. So yes. So are the triangles congruent? Yes, because all the corresponding angles are congruent, all the corresponding sides. Now, pay attention. If I do MOS, is congruent to what? Be careful. What corresponds to M? E. How did you know? Double arc. Find the double arc. Okay. O. What corresponds to O in the right? O. Triple. Triple. What corresponds to S? K. Single arc. Single arc. That's the way you think through that to get that to match. If two angles of one triangle are congruent to two angles of another, what must be true about the third? Why? They didn't, oh, yeah, they are. Let's see if, no, it didn't tell us the triangles are congruent. What do you know about the sum of the angles? They have to add to what? So if this has to add to 180, and this has to add to 180, and this sum is equal to that sum, does it make sense that when you subtract that those are going to have to be equal? Okay, so that's a concept that was in this section. If two angles of one triangle are congruent to two angles of another, it forces the third angles to be congruent. Some people aren't writing this. Thank you, Karen, for writing this. Kayla, Becky. Did you write it? Look, I paused. I paused. I don't know where this came from, but it's so annoying. And I don't know how to get rid of it. All right, two angles congruent to two angles of another, it forces the third to be congruent. So in our last example, we had vertical angles. But this allows us not to have vertical angles, and the third angles will still have to be congruent. So, are triangle LEF and AEF congruent? What do we know? If these two sides are congruent, what angles must be congruent? These two sides are congruent. Ignore EF. This is part of your test Friday. If LE is congruent to AE, what must be congruent as far as angles? MJ? MJ? You sleep, you make this time up after school. If EL and EA are congruent, what angles are congruent? Anybody know? We want an angle. Why is L congruent to A? Remember, if two sides of a triangle are equal, angles opposite are what? Equal. All right. Is there anything to tell us that these angles are congruent? Can't go by diagram. Is there anything to tell us that? No. Is there anything to tell us that this segment is equal to this segment? We don't know that that's a midpoint. We don't know that this is a perpendicular bisector. Do I have enough to do congruence? We do not know. Maybe. Maybe not. All right. The last problem I did, we were able to get all sides equal and all angles equal. Now, EF is the perpendicular bisector of LA. What does that mean about this angle right here? It's what? 90. What about this angle over here? 90. If these two sides are equal, what else is congruent? L is congruent to what? If two angles in this triangle are congruent to two angles in that triangle, from the theorem we just had, what do we know about these two angles? They must be what? Congruent? What do we know about bisector? What does that perpendicular bisector to do L to LA? It what? Bisects it? Is EF a side of this left triangle? Jennifer? Is EF a side of the left triangle? Okay. Is EF a side of the right triangle? Okay. Does it make sense that this EF is congruent from the left triangle is congruent to EF from the right triangle? Because it's the same segment. Now, do I have all three pairs of segments congruent? Do I have all three pairs of angles congruent? So are these triangles congruent? Yes. See the difference a perpendicular bisector makes? All right. That's the conclusion of these notes.